Hey there, science fans. Have you ever imagined a world where light bends in ways we never thought possible, where objects seem to vanish into thin air? It sounds like something straight out of science fiction, right? Well, get ready to have your mind blown because this is the incredible world of metamaterials. Metamaterials are not your average materials. They are engineered materials with unique properties not found in nature. These special properties come from their internal structure, which is carefully designed at a microscopic level. Imagine tiny building blocks, smaller than the width of a human hair, arranged in precise patterns to interact with light and other waves in extraordinary ways. This is where things get really exciting. By manipulating these tiny building blocks, scientists can create metamaterials that bend, twist, and control waves like never before, leading to mind-boggling applications. Are you ready to dive into the fascinating world of metamaterials? Let's go. So, how do we actually make these amazing metamaterials? Well, it all starts with a deep understanding of how waves like light and sound interact with matter. We know that materials have different properties, like how well they conduct electricity or how much light they absorb. These properties depend on the type of atoms in the material and how they are arranged. Metamaterials take this concept to a whole new level. Instead of relying solely on the inherent properties of atoms, we engineer the structure of the material itself to achieve specific effects. Think of it like building with Legos. We use tiny, repeating units called meta-atoms as our building blocks. These meta-atoms can be made from various materials like metals or plastics and are designed in specific shapes and sizes. By arranging these meta-atoms in carefully designed patterns, we can create materials that interact with waves in completely new and unexpected ways. This precise control over the material's structure allows us to manipulate waves like never before, leading to some truly astonishing phenomena. Get ready to explore these mind-bending properties in the next section. Now, let's talk about the superpowers of metamaterials. One of the most fascinating properties is their ability to exhibit negative refraction. You see, when light passes from one material to another, it usually bends at a certain angle. This is called refraction, and it's why a straw in a glass of water appears broken. But with metamaterials, we can create materials with a negative refractive index, meaning light bends in the opposite direction than we'd expect. This mind-bending phenomenon opens up a whole new world of possibilities. Imagine lenses that can focus light to a point smaller than its wavelength, allowing us to see things at an unprecedented level of detail. But wait, there's more. Metamaterials can also manipulate light to create invisibility cloaking. Remember those sci-fi movies where objects disappear into thin air? Well, with metamaterials, we're getting closer to making that a reality. By guiding light around an object, we can make it appear invisible to observers. Isn't that amazing? Let's take a closer look at some real-life examples of metamaterials in action. One groundbreaking application is the development of superlenses. These incredible lenses utilize the negative refractive index of metamaterials to overcome the limitations of conventional lenses. Traditional lenses, like those in microscopes and telescopes, have a fundamental limit on how small an object they can resolve. This limit, known as the diffraction limit, prevents us from seeing objects smaller than the wavelength of light we're using to observe them. Superlenses, on the other hand, can focus light to a point smaller than its wavelength, smashing through the diffraction limit. This means we can potentially see things in much finer detail than ever before, opening up exciting possibilities in fields like medical imaging, nanomanufacturing, and data storage. Imagine being able to see individual viruses or the intricate details of DNA. Now let's talk about everyone's favorite invisibility cloaks. While we haven't quite reached Harry Potter levels of invisibility yet, metamaterials are bringing us closer to this seemingly magical feat. Remember how we talked about metamaterials bending light in unusual ways? Well, scientists are using this property to create cloaking devices that can render objects invisible to certain wavelengths of light. By carefully designing the metamaterial structure, we can guide light waves around an object, making it appear as if the object isn't even there. The first experimental demonstrations of invisibility cloaking were conducted in the microwave region of the electromagnetic spectrum. While these early cloaks were bulky and imperfect, they paved the way for further advancements in the field. researchers are now working on developing cloaking devices that operate at visible wavelengths, bringing us closer to the dream of true optical invisibility. Section 6. Metamaterials in our lives, from smartphones to solar panels. You might be surprised to learn that metamaterials are already impacting our lives in numerous ways. While some applications are still in the research phase, others have already found their way into commercial products. One area where metamaterials are making waves is in wireless communication. The antennas in our smartphones, tablets, and other wireless devices rely on metamaterials to enhance signal reception and transmission. These tiny metamaterial structures help antennas operate efficiently across a wider range of frequencies, leading to faster data speeds and more reliable connections. Metamaterials are also playing a crucial role in advancing solar energy technology. Researchers are developing metamaterial-based solar cells that can absorb sunlight more efficiently than traditional silicon-based solar cells. These next-generation solar panels could significantly boost the efficiency of solar energy conversion, making renewable energy sources more viable and accessible. Section 7. The future is transforming healthcare and communication. The future of metamaterials is brimming with exciting possibilities. In healthcare, metamaterials hold immense potential for revolutionizing medical imaging and treatment. Imagine super-resolution microscopes that allow doctors to see individual cells with unprecedented clarity, enabling earlier and more accurate disease diagnosis. Metamaterials could also pave the way for targeted drug delivery systems. Imagine tiny, biocompatible capsules coated with metamaterials that can deliver medications directly to specific cells or tissues in the body, minimizing side effects and maximizing therapeutic efficacy. In the realm of communication, metamaterials could usher in an era of ultra-fast data transfer and optical computing. Imagine optical fibers that transmit information at the speed of light using light instead of electricity, leading to blazing fast internet speeds and seamless connectivity. Metamaterials could also pave the way for optical computers that process information using photons instead of electrons, potentially revolutionizing computing power and efficiency. Section 8. Challenges and opportunities, the road ahead for metamaterials. While the potential applications of metamaterials are vast and inspiring, there are still challenges to overcome before these technologies become widespread. One major hurdle is the cost of manufacturing metamaterials. Creating these intricate structures at the nanoscale can be complex and expensive, limiting their accessibility for certain applications. Another challenge is the durability of metamaterials. Some metamaterials, especially those made from delicate structures, can be fragile and susceptible to damage from environmental factors. Researchers are working on developing more robust and durable metamaterials that can withstand real-world conditions. Despite these challenges, the field of metamaterials is rapidly evolving. Scientists and engineers around the world are constantly pushing the boundaries of what's possible, exploring new materials, fabrication techniques, and applications. The future of metamaterials is bright, and we can expect to see even more groundbreaking discoveries and innovations in the years to come. Section 9. Conclusion: a revolution in the making. Metamaterials represent a paradigm shift in the way we interact with and manipulate the world around us. By harnessing the power of engineered structures, we're unlocking extraordinary properties and capabilities that were once thought to be the stuff of science fiction. From superlenses that can see the unseen to invisibility cloaks that bend light itself, metamaterials are poised to revolutionize countless industries and aspects of our lives. As we continue to explore the vast potential of metamaterials, we can look forward to a future where the impossible becomes possible. The journey into the world of metamaterials has just begun, and it's a journey filled with wonder, excitement, and the promise of a brighter future shaped by the power of human ingenuity. Keep exploring, keep questioning, and keep your eyes on the horizon, because the future of metamaterials is limited only by our imagination.